Squaring a number and taking the square root of their number are inverse operations. So when you square a number, that's 3 squared, that equals 9, or negative 3 squared equals 9. If you were to look at the square root of 9, if you have a variable involved, it could be either 3 or negative 3. So a couple things about roots. A square root specifically is what you've been exposed to the most at this point. It is one of a number's 2 equal factors. The symbol for square root is the radical sign. So this right here is your radical sign. And that is the symbol for square root. We've all done square roots at this point. So now we're going to get into the term cube root. So just like square root means 2 equal factors, cubed root means 3 equal factors. You'll notice that it is the same sign. So we have that same radical, but you have a little tiny number in there that is a 3. All right, so that is the index. That's called the index. So that little 3 inside your radical is called the index, and it tells you what root you are looking for. In this case, the third root. You can find any root, 5th root, 7th root, 10th root. It doesn't matter. It is the number that multiplies that many times to get to the number on the inside. All right? Your index tells you how many you're looking for, and you still use this same radical symbol. So they use the example 8. 2 cubed equals 8. So if I were looking for the cube root of 8, I would say, well, 2 times 2 times 2 equals 8. 1, 2, 3. 3 times is how many times it repeated. That is the root. And so that's how you do all roots. Basically what we're going to do is we're going to use our prime factorization to do it. All right, so we're going to go back to the factor tree that we talked about that some of you saw and some of you have not seen, but we've now done it in here. And we are going to be looking for roots based on the number that it gives us. So let's look at these first 2 examples. Find the indicated roots. If there is no index, you go back to your basic square root. So it is understood. If there is no index, it is understood that it is the square root. All right? And so we do the basic square root of 4. Well, we know that is to be 2. Square root of 16, that is 4. But you have this negative in front of it, which carries over. So that answer would be negative 4. All right? If they don't give you a symbol in front of it, you assume you're looking for the positive root, by the way. All right? So if they don't tell you the negative root, even though negative 2 times negative 2 does equal 4, if they don't tell you, you're going to assume the positive root. All right? Now, that's not true with variables when you throw variables in. So when we start solving, we're going to consider something a little bit differently. But when it's just a number like this, you consider whatever root they ask for. Let's look at example 2. Example 2. Find the indicated root. All right? So here, we're going to look and we're going to see that they want the third root of 125. If you do not automatically know the root, you can use your factor tree. So I can say, well, I know that 5 goes into 125. It goes into it 25 times. And I know 25 breaks down to 5 and 5. And once you get your prime factorization, you're going to go back to your index and say, how many times does it have to group in order to be a root? Well, it has to group in this case 3 times. So I'm going to say, well, 1, 2, 3, there's a group. My cubed root of 125 is 5. All right. Look at the next one. Which root am I looking for B? What root am I looking for B? The 4th root. So I need something that groups 4 times. Again, you can use your prime factorization. You know that 9 and 9 make 81. You know that each of those makes 3 and 3. I need something that groups 4 times. 1, 2, 3, 4. So my 4th root of 81 is 3. Question. So if the 4th root of 81 is 3, then 3 to the 4th must equal 81. right? Just like 2 squared has to equal 4 for that to be true. So your whole answer is 3. That's your entire answer is just 3. Yep. There are some rules that start getting applied to these, all right? Because remember, you have to multiply to get there, all right? So for this first one right here, I want the square root of -4. What I'm asking for is I need a number that multiplies by itself to get -4, all right? And so part of you might want to say, well, that must be -2. But the problem here is if I do -2, then I'm saying, well, -2 times -2 must equal -4. Is that true? It is not true. All right? That's not true. And so I actually cannot take the square root of -4 because I'm saying that something has to multiply by itself to get negative. But by definition, in order to get a negative number with multiplication, one of them has to be positive and one has to be negative. Those are 2 different numbers. Yes, I could say +2 and -2 multiply to give me -4, but those are not the same number. So therefore, I can't have a root. So this is actually no solution. I don't have a solution to the square root of -4, not in the real number world, okay? And that's because my index is even. If my index is even, it means that they're going to pair up. And anytime something pairs up to multiply, it's going to be positive, all right, if it's the same number, right? I can't have 2 of the same number multiply and get a negative number. That's not possible, all right? But let's look at the next one. Here I have the cubed root of a negative number. It is possible to have the cubed root of a negative number. Because think about it. If my answer is negative, I would have a negative times a negative times a negative. Third root, right? A negative times a negative times a negative is going to be a negative number. And so that's perfectly fine. My answer here is just going to be negative. All right, let's look at fractions then. Cubed root of a fraction. When I take the cubed root of a fraction, I just need to take the cubed root of the top number and a cubed root of the bottom number. So I just do them individually. What's the cubed root of 27 then? What number multiplies 3 times to get 27? 3. How do I know that? Well, if you don't know, you can just do your factor tree. 3 and 9, 3 and 3. And you can see that you're going to get 3 grouped 3 times. So that is my numerator. What multiplies to give us 125? We just did it. It's 5. And because I specifically want a negative, my answer is -3/5. You can check these, all right? What this is saying is that -3/5 times itself 3 times should equal -27 over 125. And is that true? I did the cubed root. So is that true? 3 times 3 times 3 is 27. 5 times 5 times 5 is 125. And a negative times a negative times a negative is a negative. That is true. So that is my answer. So the first thing I want to do when I have a negative inside any radical is make sure that I can do it. What is my index here? 5. My index is odd. If my index is odd, it can be positive or negative. If my index is even, it can only be positive inside. Okay? So my index is odd. It's okay that it's a negative. All I have to do is worry about what groups, how many times. How many times do I have to group to be able to come out of this radical? What's my index? What's my index? My index is 5, so I need it to group 5 times. So I'm going to use my factor tree. What groups 5 times? 1, 2, 3, 4, 5. So my answer is 2. And then because it was negative, my answer is going to be -2. -2. So your index tells you what grouping you are looking for. What grouping are you looking for to be able to take it out of the radical? What about the second one? So the square root of 196 is 14. What's the problem with this, though? It is a negative, right? And what is my index? If you don't see an index, it's what? 2. It's 2. That's even. So this one is not possible. Not a real number. So logically here, 4 is less than 7, which is less than 9. Okay? Why do they tell me that? Because what we're trying to do here is we're trying to estimate the square root of 7. Oh, we don't want to color that out. Trying to estimate the square root of 7 here. Square root of 7 doesn't have a perfect root, right? But 4 and 9 do, right? So 4 has a perfect root and 9 has a perfect root. So when you have a number that is not a perfect root, like 7, you're going to look for the closest perfect root above it. Well, that's 9. 8 doesn't have a perfect root. 9 does, right? And the closest perfect root below it. All right, 6 and 5 do not have a perfect root. 4 does, all right? You know what the square root of 4 is. That's 2. You know the square root of 9. That is 3, which means the square root of 7 must fall somewhere between 2 and 3, right? So if you were to have to graph this on a number line, you would graph it somewhere between 2 and 3 because that's where it's going to fall, right? 3 is going to be bigger than it. 2 is going to be smaller than it. And somewhere between 2 and 3 is going to be your square root of 7. And that's where you get into estimation. So like they gave us an even larger one here. Mentally estimate 129, which is like way huge. What I would say here is think about your numbers when you start squaring them. So like you have 10 squared, which is what? 100. 11 squared is 12 squared is. So it's going to be in between which two? Yeah, it's so somewhere between 11 and 12 is going to be the square root of 129. And that's how you would do that process if you were trying to mentally estimate what is my root here. Do it. So when like on a quiz or test, if I were to say mentally estimate this, this is what I'm looking for. Oh, we don't have it on a triangle. Yeah, where you just have to give me what two numbers it's in between. Okay, so that would be your answer. It's in between 11 and 12. It's really not. So I want to start with an easy one. I want to start with, they did 2/3, which is kind of crazy to think about. I want to start with just 1/2. So there is a relationship between radicals and exponents, which we've already seen that, right? So we've already seen that like 2 to the 3rd power is 8, which means the cubed root of 8 is 2. Okay, so we can already see that there's a relationship between exponents and radicals, all right? But there's actually a bigger relationship than that. You can rewrite a radical as an exponent, and you can rewrite an exponent as a radical, all right? And so one of the ways you do that is fractional, or actually the only way you do that is fractional. So I want to write one. So if I were to say the square root of 16, I could rewrite that as 16 to the 1/2. That actually means the same thing. Your numerator comes from the exponent inside here. What is the exponent on 16? 16 to what power? 16 to the 1st power, right? Is 16. Yes? Does that make sense? Yeah. All right. What's my index of my radical? If you don't see an index, it is 2. That's where that comes from. Your numerator is your exponent on the inside. Your denominator is your index on the outside. Okay? So if I said, solve then for 16 to the 1/2, if I said solve this, all I mean is this, which is just 4. Okay? That's what fractional exponents are. They are simply radicals written a different way. So then here they said 8 to the 2/3. What they mean is the cubed root of 8 squared. Now what's cool about fractional exponents is you can do one or the other first, whichever is easier, all right? So in this case, you could square your 8, 64, and then take the cubed root of 64. That's probably not the easiest way. Or you could take the cubed root of 8 and then square it. All right? Cubed root of 8 is just 2. 2 squared is 4. So if I were to rewrite this, 8 to the 2/3 is just the number 4. Okay? So you can do one or the other first. You can take the power first or you can take the radical first. It doesn't matter which way you do it. Typically, it's easier to take the radical first and you have a smaller number that you're taking to a power. So let's look at some of these. The first thing you're going to do is just rewrite them. Okay? Just rewrite them. So they want me to convert 5 to the 2/3 to radical form. So 5 to the 2/3 is exponential form. This is exponential form. They want me to write it as a radical. If I write it as a radical, my radical symbol is there. All right. My 5 is on the inside. 3 is my index. My denominator goes here. My numerator goes here. Can I simplify that? What is 5 squared? 25. All right. So then I can rewrite this as the cubed root of 25. That is 5 to the 2/3 in radical form, the cubed root of 25. So this is radical form. They gave it to me in exponent. They wanted it in radical. We can go the other direction. Look at B. They want me to convert the 5th root of x cubed to fractional or to exponential form. So they gave it to me in radical form. They want it in exponential form. So my base here is going to just be the x. What is my numerator? The 3. The 3 is my numerator. The 5 then is my denominator. And that is exponential form. So when you're rewriting it, do not overthink it. They legitimately just want you to rewrite it from one to the other. Okay? There are going to be times when it is easier to have something as a radical, and there are going to be times when it is easier to have something as an exponent. All right? Especially when you have something like this. Write that as a single radical. So if they want it as a single radical, you have to have the same index. You have to have the same index, which means you have to get a common denominator before they can go under the same exact radical. All right? So let's look at this first one, and I'm actually going to... We have 3 to the 1/2 times x to the 3/4. All right? If I want them all under the same radical, they have to have the same index when it's all done, okay? Which means the denominators need to be the same. Are the denominators the same here? They are not. How do I get them to be the same? I need a common denominator. What is my common denominator between those two? It's 4, right? So I need to rewrite this one to have a denominator of 4, okay? 1/2, what's it going to be with a denominator of 4? 2/4. Does everybody agree that's the same as 1/2? So I didn't change it, right? No. We're just changing the radicals. We're just changing the exponents. I didn't change anything, did I? 3 to the 1/2 and 3 to the 2/4 should be the same thing. Does everybody agree with that? Yeah. Yes? All right. Times x to the 3/4. So these are the same denominator, which means they're both going to be under the same root. The thing about roots is that you can multiply them as long as they have the same index. So if I were to rewrite this, I can say this whole thing is the 4th root of 3 squared x to the 3rd. Why does that work? Because if I have the 4th root of 3 squared times the 4th root of x cubed, I can just multiply what's inside. That's how radicals work. As long as it's the same index, you can multiply what's inside. and this is y. So I can rewrite this whole thing like this. And they could simplify it more. Obviously, what is 3 squared? What's this number right here? It's just 9, right? So my final simplified answer would look like this, because 3 squared is just 9.
Do you want us to do it?
All right. They want me to change this, so they've given it to me in radical form. And they want me to change this into exponential form. Every single thing inside of it is under that radical. All right. So what is the exponent on my 7 right now? 7 to the what power? The first power, right? So remember, if you don't see a power, your exponent is a 1, right? So the 7 is going to be, my numerator is 1, my denominator is 4. The x, my numerator is 3, my denominator is 4. The y, my numerator is 2, my denominator is 4. Do you think I'm finished here? No, why not?
Reduce.
Yeah, reduce. The only one that can reduce here is my y. So I am going to reduce that y. My final answer is 7 to the 1/4, x to the 3/4, y to the 1/2. That's my final answer there. Through it. So if they do not have a common denominator, you have to get a common denominator first before they can go under one radical. So my common denominator here is going to be 8. So I left my 3 to the 3/8. I changed my r to 2/8, multiply top and bottom by 2. And I changed the s to 4/8, multiply top and bottom by 4. So then I have the 8th root of 3 cubed, r squared, s to the 4th. The 8 is my index. The 3, 2, and 4 are my exponents there. And then I just simplified my 3. 3 cubed is 3 times 3 times 3, which gave me the 27. So I have the 8th root of 27, r squared, s to the 4th.